The topic on ultra-wideband antenna applications on behalf of Group B27. Well, today we'll look at a variety of topics. Our objective is to look into the introduction, why ultra-wideband antennas are looked and are progressing in the future, how their transmission and receiving works, what are the impairments that are related to it, the bandwidth exceptions or enhancements, the industrial applications, why and in what variety the ultra-wideband antennas are used in today's world. And at the end, I'll summarize everything in context. So for antennas, it is important to understand the application and deployment and operating scenario for which ultra-wideband device is used. The usage of system determines the location and on the size of the antenna. Why ultra-wideband? Currently, there is an increased interest in ultra-wideband technology for use in several present and future applications. Ultra-wideband technology receives a major boost, especially in 2002, since the U.S. Federal Commission permitted the authorization of using the unlicensed frequency band starting from 3.1 to 10.6 GHz for commercial communication applications. Although existing third-generation 3G communication technology can provide us with many wide services such as fast internet access, video telephony, and enhanced video music download, as well as digital voice services. Therefore, ultra-wideband as a new technology is very promising for many reasons. Data transmission. One of the most applications of ultra-wideband antennas is data transmission with a very high rate given the larger bandwidth of the antenna. Ultra-wideband wireless technology uses a very wide bandwidth to transmit information. The wide bandwidth provides sufficient throughput for reliable delivery of high-quality video in high definition and non-high definition formats, up to 1080p at 60 Hz. Example where high data transmission plays a role includes high-definition TV streaming from a set box or a DVD player to the TV. Requires high data rates, which aims to transmit at 480 megabits per second. The impairments related to the line of sight. Many wireless communication services require direct line of sight to be able to communicate reliably. However, in an operating room, wireless devices cannot rely on direct line of sight operation and must be designed to operate reliably even if people or equipment stand directly between the transmitter and the receiver at the same time, or wireless video systems must not cause harmful interference to other medical devices in the operating room. Bandwidth criteria. The ultra-wideband antennas are proposed for applications of communication systems. Various kinds of antenna range, test ranges, and high-resolution microwave imaging. The narrow instantaneous bandwidth of ultra-wideband antennas will degrade the performance of the above applications. Industrial applications. Another important application area is the sensor networks. Data from various sensors are sent to a central server or exchanged between different sensors. Let's look at the automotive industry today and analyze how this emerging technology has enhanced our living and expectation. For example, back collision avoidance when reversing the car, moving objects detection while driving, improved airbags activation and suspension performance. Let's also look at the security applications. Security applications will include ground penetrating radars, through-wall surveillance, tracking application, guarding objects. In conclusion, ultra-wideband as an emerging technology requires for the antenna characterization a thorough knowledge of the behavior in time domain and the frequency domain, and in certain cases in the spatial domain. I would like to say that the ultra-wideband is a developing technology, and a broader understanding in this field can create great ideas and inventions.